Hey guys, Gabe here with my Midpoint SDC conversation. So first I'd like to talk a little bit about just what this project entailed and what we actually ended up doing. So during our previous project, our front-end Capstone, we picked a popular web page. I believe we picked TripAdvisor, the other team picked Spotify, and we built sort of a dynamic user interface to recreate the usability of that front end. And then for this project, the SDC, we inherited the other team's front end and worked to sort of build and optimize their back end, including their server and their database, to be able to handle 10,000 requests per second, as well as 10 million total database entries. So it was certainly a very back-end heavy project that required a lot of optimization, a lot of picking the right tools for the job, more understanding things on a high conceptual level. So that's what the project entailed. The first thing I'd like to talk about are a couple of the interesting technical challenges that we faced in this project. So first off, the biggest challenge was actually picking the right tool for the job. So, when you're dealing with data sets of this size, modeling your database and your data store to actually fit the structure and shape of your data as well as possible is absolutely essential. So the two options that we had here coming into this were a SQL relational type database such as MySQL or Postgres, or a NoSQL schemaless database such as MongoDB or CouchDB or one of those. So this was the first big decision we had to make, and obviously there's benefits and drawbacks to all of these alternatives. Some of the benefits of picking a NoSQL schemaless design include not being sort of stuck to a rigid schema, and being able to be a little more free as your data set grows and changes in shape, to be able to adapt to that and not have to do like painful migrations to change your schema and the overall structure of your database to support your changing data. So in certain environments, that's a huge benefit and can really make scaling a small company much easier. So that would be the main benefit of a NoSQL database. As for a SQL, one of the major benefits can also be that schema. I mean, if you know that you have a specific data set that's not likely to change and that involves a lot of relationships between different tables and types of entries, then this can do a very good job of modeling this on a database, sort of modeling a real-world structure on your database. So ultimately, I did choose to go with a SQL database as my component. We worked with the Spotify artist web application. So, and I worked on the top tracks component within that application. So ultimately, my data consisted of artist entries and then track entries and the relationship between these two. And because it was relational in nature, I felt that a SQL database would be a very good choice here, and also happened to perform better under our stress testing that we conducted. So ultimately, I thought this was the best fit for our project, and also a really great learning experience, as I hadn't had too much experience with SQL databases coming into this. So that was probably the biggest challenge we faced so far. Some other interesting technical tidbits or other challenges that we faced included, so now we've made our database selection. How do we actually go and optimize this thing? Because sometimes it feels like these sorts of databases are very popular. A lot of them are open source, and they're already super optimized. So it feels like, initially it feels like there's not much you can do to really improve that process. However, through conducting some research, we did learn a ton about optimization. One of the big things we learned was that of indexing. So indexing is actually if you have you're doing some lookups on your data, and there's a field that you query by very often, you can index that field or column to where it actually creates a separate sorted version of that table, so that when you need to look up items by that field, the database knows exactly where to go and how to retrieve it. So you can retrieve things in, lightning fast if you know you're going to be searching by that field most often. I kid you not, I actually, after implementing indexing on both of my databases, I saw an average 12,000x improvement in my lookup time, which is absolutely insane. And it was super easy to implement. It only consisted of 1 or 2 command line instructions, and made an enormous difference in the efficiency and sort of usability of my application. Another type of optimization that we ended up doing was something called caching. So if you have common database entries that you're going to be looking up and asking for very often, such as maybe like if we go back to like play counts, if we're a track's play count, how often it gets played. If you're always looking for the top tracks, well, you can actually go and cache those results, and what that means is actually storing them in memory instead of having to write to and from the disk constantly, the hard disk. So implementing caching means you can actually get lightning fast results as well, because you don't have to do these expensive read-write operations. You can just fetch this data straight from memory and return it to the user. So this is something I'm currently implementing. I'm not fully done with it yet, but the results I've seen so far have been very promising. And because because of the structure of my component, I am returning the top tracks by play count. So because of course, this data does change every now and then, but for the most part, it takes a while to change these play counts in a meaningful manner. So since I'm usually always returning these same fields, these same entries, well, I can just cache these and just grab them straight from memory and return them directly to the user. So these were 2 of the super important concepts that I've learned so far in terms of optimizing a database. And so those were probably the main challenges we've faced so far, and definitely learned a lot. So that about wraps it up. I've been Gabe, and thank you for listening.